Here question number 3 is having two parts, and its first part is y is equal to 1 minus x square by under root 1 plus x square. You can use this u by v whole derivative, that is equal to v square v into u derivative minus u into v derivative. This formula can also be used, but it would be easy if we are going to take ln on both sides of the equation and evaluate it. Now question number 3, first part. Let's take ln on both sides of equation. This under root can be written as whole raised power 1 upon 2. So let's evaluate it. Ln 1 minus x square minus, this division is converted into minus, ln 1 plus x square whole raised to the power 1 upon 2. And you know that whenever ln is there, this 1 upon 2 is coming over there instead of power. So 1 upon 2 will be there. Right, let's take derivative on both sides of equation. So here we have 1 upon y dy by dx, and its derivative will be 1 upon 1 minus x square, and derivative of 1 minus x square minus 1 upon 2 will be out, and the derivative of ln 1 plus x square is equal to 1 by 1 plus x square and derivative of 1 plus x square. So dy by dx can be written as by derivative and 1 upon 1 by x square, and derivative of 1 will be 0, and this derivative of x square will be minus 2x. Here you can see this is minus, so minus will be same, and derivative of x square will be 2x minus 1 upon 2, and same derivative of 1 will be 0, and the derivative of x square is equal to 2x, and this 2 is cancelled with 2. So 1 upon y into y derivative is equal to minus x can be taken as common. The remaining will be 2 by 1 minus x square plus, as I have taken minus common, 1 by 1 plus x square. 1 by y derivative is equal to minus x into, we have to take LCM here, 1 plus x square. So as you know, this same will be cancelled, and the remaining is 2 is multiplied with 1 plus x square. So 2 into 1 plus x square plus 1 plus x square, 1 plus x square same is cancelled, and we have to multiply 1 with this remaining 1. 1 plus x square. Open this would be 2 plus 2x square plus 1 plus x square by 1 minus x square, 1 plus x square. As you know that y is divisible over there, when it will go on the other side of equation it will be multiplied. So here I am writing y as well. Y derivative is equal to minus x, y was equal to 1 minus x square by 1 plus x square whole power 1 upon 2. It was y given in your question. So it would be, yes, x square, 2x square minus x square plus 3 by 1 minus x square and 1 plus x square. So y bar is equal to minus x square and 1 minus x square are cancelled, and we are having x square plus 3 divided by 1 plus x square whole raised to the power 1 by 2 plus 1, that would be 3 by 2. So y bar is equal to minus x square plus 3 by 1 plus x square whole raised to the power 3 upon 2. And that's the answer of first part of question number 3. And this is the whole solution of question number 3, first part. Now let's move to its second part, that is, here is the second part, y is equal to under root 1 minus x by 1 plus x. Now again we can resolve it by simple method of differentiation, but it would be easy for us if we are going to take ln on both sides of equation and evaluate ln, and afterwards taking the derivative on both sides of equation. Same here we have done in question number 3, first part. So let's resolve this part as well. Question number 3, second part is y is equal to 1 minus x this under root can be written as 1 upon 2. Taking ln on both sides of equation, so it would be ln y is equal to 1 upon 2 1 upon 2 ln 1 minus x by 1 plus x. And further we can resolve it. Ln y is equal to 1 upon 2 ln 1 minus x minus ln 1 plus x. Fine. Now afterwards taking derivative on both sides of equation, it would be 1 upon y dy by dx is equal to 1 upon 2 is same outside, and derivative of ln 1 minus x minus derivative of ln 1 plus x. 1 upon y dy by dx is equal to 1 upon 2 ln 1 minus x is equal to 1 upon 1 minus x, and derivative of 1 minus x minus 1 upon 1 plus x, and derivative of 1 plus x. 1 upon y derivative is equal to 1 upon 2 1 by 1 minus x, and derivative of this 1 will be 0 and minus x will be minus 1. Minus derivative of this will be 1 will be 0 and x derivative will be 1. So y derivative is equal to, this is in the denominator and it will be multiplied there. Minus can be taken as common, 1 by 1 minus x, plus as minus is taken common, 1 by 1 plus x. It would be y derivative 1 minus x 1 plus x, and here you can see that 1 minus x is cancelled with 1 minus x, so 1 will be multiplied with the remaining one. So here it would be 1 plus x, plus, as you see that here is 1 plus x with cancelled with 1 plus x, and remaining 1 minus x will be multiplied with 1. So answer will be 1 minus x. X is cancelled with x. Y is equal to 1 minus x by 1 plus x whole raised to the power 1 upon 2 into 2 by divided by 2. 1 minus x 1 plus x 2 is cancelled with 2. Y derivative is equal to this whole 1 upon 2 power can be separated as 1 minus x whole raised to power 1 upon 2 by 1 plus x whole raised to the power 1 upon 2. So the numerator power can be numerator and denominator powers can be separated. 1 minus x, this positive power when it go in numerator, so it will be minus 1, and 1 plus x power 1. This 1 upon 2 minus 1 upon 2 is minus 1 upon 2 by 1 plus x whole raised to the power 1 upon 2 and 1 plus x power 1. So y derivative is equal to minus 1 upon 1 plus x 1 plus x whole power 1 upon 2, and when this numerator power goes down into the denominator, it will be positive. 1 plus x. This whole 1 upon 2 can be written as under root. This and this both can be written into 1 under root. So this would be the answer of question number 3, second part.